In the case of refrigerator, the heat is transferred from a lower temperature to a higher temperature. This is a reverse process and it cannot occur by itself. So we need an external work input to the refrigerator, which is given by a compressor. Uh, in the evaporator, the vapors, the refrigerant is vaporized, which produces the cooling effect. So now the vapors travel in this direction to the compressor, where the vapors are compressed, so its pressure and temperature is raised. So it is raised from minus 20 degrees centigrade to 60 degrees centigrade, and the pressure is raised from 120 kilopascal to 800 kilopascal. So when the pressure is raised and temperature is also raised, so we can condense the vapors in the form of liquid with the help of an condenser. Condenser are the coils which are placed outside of the refrigerator, that you might have seen in your kitchen refrigerator, that there are coils at the back side of the refrigerator. That coils are called as condenser. So the function of these coils is to reject heat. Its function is to reject heat from the hot refrigerant to the surrounding. So if you touch those coils, so you will feel them that they are hot. So when the vapors transfer its heat to the surrounding, the vapors are then converted into liquid, and you can see its temperature is now came down to 30 degrees centigrade, and it is now converted into liquid, but the pressure is same. So at the outlet of the condenser, pressure is not dropped, but temperature is dropped. This is due to the transfer of heat to the surrounding. Then there is a device called expansion valve. So when the refrigerant is passed through this expansion valve, its pressure is suddenly decreased. Due to the decrease of pressure, the refrigerant is evaporated, and due to this evaporation a cooling effect is produced. You can see here, when we have decreased the pressure from 800 kilopascal to 120 kilopascal, its temperature is drastically dropped to minus 25 degree centigrade, and it is done due to the vaporization of the refrigerant. This vaporization process is producing cooling effect, and this expansion process is continued in the evaporator. The evaporator is placed inside of the refrigerator. So heat engine we get work output, but in the case of refrigerator we are giving work input. So everything is in the reverse direction. You can see here, normally the heat is flown from warm environment to cold environment. First we need to understand the different components of a refrigerator. You might see seen these condenser coils at the back side of the refrigerator, and this is a compressor. This compressor is compressing it to a high pressure. This high pressure vapor is then traveled from these condenser coils, and which rejects heat to the environment in the form of QH, and then at the end of this process vapors are turned into liquid. At this point, it is liquid, and these capillary tubes act as a expansion valve. Here, the pressure is decreased and cooling effect is produced due to the vaporization of refrigerant. Then the vapors are passed through the evaporator coils. This is the freezer portion in your refrigerator where the uh, kitchen goods are frozen, which can be meat or anything else. So in the lower portion there is temperature at refrigerant is at 3 degrees centigrade. So we measure the performance of this refrigerator with a term which is called coefficient of performance. Our desired output is the cooling effect. This is the cooling effect, and work is given to the compressor in the form of electricity. That is our work input. Go to example of for further clarification of this problem. The food compartment of the refrigerator is shown in figure is maintained at 4 degrees centigrade. This is the inside of a refrigerator which is maintained at 4 degree centigrade. Amount of heat which is uh, removed from the refrigerated space is equal to 360 kilojoule per minute, and the power input required for the refrigerator is 2 kilowatt. So W net is equal to 2 kilowatt. So first he's asking you to determine the coefficient of performance. So we know coefficient of performance is equal to QL, which is the cooling effect produced by the refrigerator divided by the input in the form of work, which is W net. So QL is 360. It is given in kilojoule per minute. We convert it into per second and divided by W net, which is 2 kilowatt. So coefficient of performance is calculated as 3. Note that coefficient of performance is always greater than 1, which is uh, might not have seen in the case of efficiency. Efficiency is always less than 1, and coefficient of performance is always greater than 1.